Hi friends, in this session we are going to solve one numerical on single degree of freedom damped system. Okay, so the system is damped, so that here you can see in the numerical they have given the graph of displacement against time, and in each cycle you can see the displacement at first cycle it is 5 mm, means amplitude is 5 mm, and its second cycle it is 2, and in third cycle it is 0.75. Okay, so with respect to this graph we can determine the values which are required in the problem statement. So just read the problem statement. In the free vibration record of 1 ton machine, so in the given they have given that the mass of that machine is 1 ton, so it is 1000 kg, which is mounted on the isolator as shown in figure. Identify the type of isolator, its characteristics, that is the spring stiffness. So we'll have to determine the spring stiffness. Now whenever we see such type of graph, then keep in mind that it will be related to the logarithmic decrement, and the formulas which are required for this solution that I am going to write. The first formula will come that from this graph is the logarithmic decrement, that is the delta, and this logarithmic decrement which is given by two formulas. I'll write both the formula. The first formula is 1 divided by n log to the base e x naught by xn. Now what is this x naught and what is this xn? This x naught is the amplitude for first cycle, means here you can see the amplitude for first cycle is 5 mm, and xn means amplitude for nth cycle. So suppose if I consider 2 cycles, 3 cycles, so after first cycle the amplitude is 2.09. So if I consider number of cycles n is equal to 1, then the xn value is 2.09, and if I consider this xn means second cycle, then this value will be 0.75, and here we will have to put the value of n is 2. So you can select any number of cycles because they have given almost 4 cycles in this graph. Okay, along with that they have also provided the time period. See, from this point to this point means one cycle is completed, and for one cycle they have provided the time period. So in the given I'll mention the time period is 0.64 seconds. Okay, now this is the first formula for the logarithmic decrement. The second formula for logarithmic decrement is delta is given by 2 pi zeta divided by root 1 minus zeta square. Now what is mean by this zeta? Zeta is nothing but the damping factor, or sometimes it is called as damping ratio, means zeta is damping ratio. So if I solve from this one, if I put the value of x naught and xn, then we'll get the value of delta, and if I put the value of delta here, ultimately we are going to get the zeta. Now how to convert that zeta into spring stiffness, that we'll see later. So initially we'll solve for this delta value, that is the logarithmic decrement. So consider any number of cycles. So I'll consider, if I consider 5 mm and 2.09, then there will be one cycle. If I consider 5 0.75, then we will have to consider 2 cycles. You can consider any number of cycles. They have given here 4 cycles, so consider 2 cycles. So I have considered 2. If anyone wants to consider 3 cycles, anyone wants to consider 4 cycles, yes, you can use any number of cycles. Depending upon that, the value will be putted, but the answer will be same. So consider 2 cycles. The logarithmic decrement is given by, what is the formula for logarithmic decrement? This formula is delta is equal to 1 divided by n log to the base e x naught divided by xn. Now we have considered 2 cycles, so we'll have to put the number of cycles is equal to 2. So delta is equal to 1 by 2. Suppose if I select only one cycle, then in that case I'll have to put n is equal to 1. Now for 2 cycles I'll have to select x naught means initial amplitude and xn means amplitude after 2 cycles. So initial amplitude it is 5 divided by xn means after 2 cycles. So this is the first cycle completed, here the second cycle completed. So this value is 0.75. Suppose if I select one cycle, then here the n will be 1, instead of 2 I'll write 1, and here instead of 0.75 I'll write 2.09. Okay, so solve this one to get the value of delta. So after solving on the calci, we'll get the value of delta, and this delta is nothing but 0.978. There is no unit to this delta because it is the logarithmic decrement, means it is the ratio of the 2 amplitudes. So whatever the values here you are going to put in mm or in meter, in centimeter, that unit will be cancelled. So I have not converted this mm into meter. Okay, I have directly put all the values of amplitude here. Okay, and this is the unitless quantity. So we got the logarithmic decrement. Okay, now from logarithmic decrement, by using logarithmic decrement we can determine the zeta value, that is the damping factor. So I'll continue with this derivation, but the second formula for delta is, that is the logarithmic decrement is 2 pi zeta divided by root 1 minus zeta square. Okay, it is 2 pi zeta divided by root 1 minus zeta square. So we'll solve for this one. So put the value of zeta, put the value of delta, that is logarithmic decrement, 0.978 is equal to 2 pi zeta divided by root 1 minus zeta square. Now to solve this one, I'll transfer this denominator on left side. So 0.978 into root 1 minus zeta square will be equal to 2 pi zeta. Okay. Now so we'll make the calculations. Now to make the calculations, square on both the sides. So 0.978 square into 1 minus zeta square is equal to 4 pi square zeta square. Square on both sides. Okay, so I have taken the square on both sides. Now multiply by this value inside. So this will be 0.978 square into 1 minus 0.978 square into zeta square is equal to 4 pi square zeta square. Now transfer this zeta square on that side. So it will be 0.978 square equal to 4 pi square zeta square plus 0.978 square zeta square. Now here the zeta square is common, so we can take common zeta square. So in bracket 4 pi square plus 0.978 square, and here it is 0.978 square. Now transfer this value on this side and take the root. Transfer this value and take the root. So I'll directly solve this one on calci. So 0.978 square divided by this value, and we'll have to take the root of answer. and the answer which comes out to be 0.15. Okay, so the damping factor is 0.15. So here I'll write, therefore the damping factor is 0.15. Okay, so this is 0.15. Now, but in the question they have asked to identify the spring stiffness. Okay, so to determine the spring stiffness, or they have also called its characteristics. So we'll have to determine the characteristics of this system. Means characteristics means for any system there will be spring, there will be damper. So we'll have to determine the spring constant K and damper constant C. So here I'll write the character means we will have to determine the damping coefficient and the spring constant. These two values we will have to determine. Now how to determine this one? Yes, we'll see. Now we have the value of zeta, but the value of formula for zeta is nothing but C by Cc. So to determine the C, we will have to determine Cc. Cc is nothing but critical damping coefficient. So we will have to determine the critical damping coefficient. Now I'll write the formula for the critical damping coefficient. So Cc is nothing but 2m omega n. 2m omega n. So from this formula we can determine the value of Cc. Okay, but here we don't know the value of omega n. We'll have to identify the omega n. So for that I'll go to the given. Yes, you can write this formula, modify this formula. Omega n is nothing but root k by m, but we don't know the value of k. So we cannot determine the value of Cc and we cannot determine the value of C. So right now I am not going to use this formula and this formula because we don't know the value of k. But in the given they have given that the time period. Just see this time period. The time period which is given is 0.64. Now from this time period we'll see what we are going to get. So here I'll write the one more formula. Time period is nothing but 1 divided by omega. Time period is nothing but 2 pi by omega. Okay, 2 pi by omega. But the system which is given for us is damped system. So the formula will be 2 pi by omega d, means damped frequency, 2 pi by omega d. So Tp equal to 2 pi and formula for omega d is root 1 minus zeta square into omega n. And from this formula of time period we can get the value of omega n. So I am going to use the formula time period. Now time period is given by what is the formula for time period? 2 pi by omega, but in our case the omega is omega d. Why omega is omega d? Why this omega is omega d? Because the system that they have provided is damped system. So we will require the formula of omega d, and the omega d is given by under root 1 minus zeta square into omega n. Keep remember that this omega n is out of that root. Omega n is out of that root. It is not in the root. Okay. So just I will make one change. 1 minus zeta square into omega n. Now put the value of time period. What is the value of time period? Just check. The time period which is given is 0.64. Okay, so I'll write here 0.64 is equal to 2 pi divided by, we have the value of zeta, So write 1 minus value of zeta is 0.15 square into omega n. Now transfer this omega n on this side and transfer this 0.64 on this side. So 2 pi divided by root 1 minus 0.15 square into 0.64. This 0.64 is out of that root. Okay. Now put the values, we will get the value of omega n. So solving on Cal C will get omega n. Just wait, I'll solve to get this answer. Okay. Now this omega n is 9.9 and the unit is radian per second. Okay. Now we have the value of omega. Now again go to the formulas. From this time period we got the value of omega. Now we can determine the value of Cc, that is the critical damping coefficient. Now the next one is critical damping coefficient. Now critical damping coefficient is nothing but 2m omega n. Now put the value. 2 m mass is given as 1 ton, so it is 1000 and omega n is 9.9. From this we will get the critical value of coefficient, damping coefficient, and put the value on Cal C, we will get the answer, and this answer is 98010. This answer is 98010. The answer for CC is 19800. Sorry, the answer is 19800. 19800. Okay, and the unit for CC is, actually it is damping coefficient means force per, it is, what is this CC? The formula for CC, it is the force. Here I will write to determine the formula. The force acted upon by the damping coefficient is C into x dot, that is damping coefficient into velocity. So C is nothing but F divided by x dot. So F, force is in Newton per, velocity is meter per second, that second will go here. So Newton second per meter. So this is the unit of damping coefficient. So we got the critical damping coefficient, but actually we want, what we want? We want the value of C. Okay, so C means damping coefficient. Now we can write the formula of zeta. Zeta is nothing but C by Cc. We have the value of zeta. Zeta is 0.15. We have the value of Cc. Cc is 19800. So transfer this 19800 on that side, you will get the damping coefficient of your system, and this will be your answer. Answer number 1. So 0.15 into 19800, it will be 2970 Newton second per meter. Okay, so this is your answer 1. So we got the value of C, but they have asked one more answer, and that answer is mass. Mass nahi. They have asked for value of K, that is the stiffness. Now to determine the stiffness, we have the value of omega n. Now use the formula of omega n. What is the formula of omega n? It is under root K by M. Okay, now just see the value of omega n. Go back and see the value of omega n. We have determined it is 9.9. Okay, so I'll put here 9.9 is equal to root, we don't know the value of K, but we have the mass, it is 1 ton, so it is 1000. Now square on both sides and determine the answer. Square on both sides and determine the answer. So it is 9.9 square is equal to K divided by 1000. Now transfer this 1000 on that side and this answer comes out to be 98.01 into 10 raised to 3. Okay, so this is the stiffness of the system, and unit of stiffness is nothing but force divided by displacement. So force is Newton, displacement in meter. Okay, so K will be 98.01 into 10 raised to 3 Newton per meter. Okay, so the problem which is given for us is completely depend upon the damped vibration, and in the damped vibration the formulas that I have used is, first one is of logarithmic decrement, again then logarithmic decrement, then we got the value of zeta, so I have used C by Cc, but we don't know the value of K. So in the given, they have given the time period, from the time period I have determined the omega n and I have put this omega n into Cc, so we got the value of C, and from that C again by using the omega n formula we got the value of K. So this is the simple numerical which is on damped vibration. Okay, please go through it. Thank you.